Okay, now we get to the second complication. When we look at a galaxy like M33, we see the stars, we see the gas, and we measure the velocities. In the case of M33, if we look at the velocity at the edge of the stars, that's at a distance of about 35 arc minutes, and the velocity here observed is about 97 kilometers per second. When we deproject that, dividing by cosine of 38 degrees, that's a V true of about 123 kilometers per second. And then when we measure the velocity out here at the edge of the gas, we're now talking about a distance of 80 arc minutes. An observed velocity there of about 130 kilometers per second, which once again deprojecting gives you velocity, the true velocity of about 168 kilometers per second. But the first problem we have is we don't actually know the distances. We don't know how far this is from the center of the galaxy, which we're going to need to do our calculation. All we know is the angle, how far we have to tilt the telescope. So we point the telescope at one angle to look here and tilt it at a different angle to go there. We know that angular difference, but we need to convert that into a physical distance, something that is necessary in all areas of astronomy. So let's remind you of how you do that. We've got the Earth, our eyeball, over here, and we know the distance to M33, call it big D, which in this case is 900 kiloparsecs. And let's say we've got two things which are separated by some angle theta. Here's an angle theta, and this might be, for example, the middle of the galaxy and the edge of the stars, or the middle of the galaxy and the edge of the gas, or any other two things that are separated. We want to work out r. What we know is theta and d. How do we do this? In astronomy, angles are very, very small. These angles are a few arc minutes. An arc minute is a 60th of a degree, so these are much, much smaller than a degree. So what we can do is use a small angle approximation which says that theta, as long as you measure it in radians, is just equal to r over d. So in this case, that tells us that r is going to be d theta, and we have to convert theta from arc minutes to radians. So 1 arc minute is equal to 1/60th of a degree equals 1 over 60 times pi over 180 radians. So we can work out that r corresponding to 1 arc minute is therefore 1 over 60 times pi over 180 times 900 kiloparsecs. So it's 900 times 1000, because it's a kiloparsec, times a parsec, which is 3.086 by 10 to the 16 meters, which comes out as about 8 by 10 to the 18 meters, which is 262 parsecs. So that's how we do the conversion, which will allow us to calculate exactly how far out these measurements actually are.